Hello everyone, this is Krishna Puja Anumula. I'm thrilled to welcome you all to the today's presentation on our project Road Traffic Sign Detection using Deep Learning. We are using RESNET in this. Before we dive more into the details of our project, let me take a moment to introduce my other team members. My another team member is Sai Narasimha Reddy Anumula and Suresh Babu Changanaboyina. And our academic advisor is the Professor Muhammad Karakaya. And let me introduce our problem statement. Across the globe, many researchers consistently identified that the ignored traffic signs and human errors are the leading contributors to the road accidents. And these are few studies from 2021 research from US, India, and UK. We can see from the graphs that the major problem is overspeeding, human faults, that is the ignored traffic signs that takes the lead place that cause the road accidents. And our mission is to tackle these prevalent issues and using the leveraging advanced technologies. Our aim is to develop a model that can identify and classify the road traffic sign images such that a model can be developed which could be a heart of an intelligent transportation system which can monitor the road signs and warns the users uh, about the overspeeding and crosswalk signs and traffic signals and alert them to lower their speed or to observe for the pedestrians, so on. So, in the current phase, we focused on identifying and classifying the road traffic signals into four predetermined classes. Our model uses powerful ResNet architecture and we use transfer learning. Sorry. First, we extract the features from the lower levels of the ResNet and we classify the images in the final layer. Why we choose ResNet? ResNet is a revolutionized deep learning model and it has a clever skip connection method by which we can bypass few layers so that we can avoid the vanishing gradient problem so that the model can learn better. In our case, there is a very much need for us to identify the road signs very clearly because there can be varied display of signs and there can be multiple signs in at the same place. So it is very important for us to identify the road signs very precisely. So we are using the ResNet and the ResNet perfectly fulfills our need. And the skip connection is the major thing that really helps us to identify the models and classify the images better. So we have choose ResNet for our requirement. Next, we are now delving deep into the designing. So first we have collected around 1450 samples from different sources of different traffic sign images. And we divided the samples into training and test sets and labeled them into four main predetermined classes. They are traffic lights, stop signs, speed limit signals, and crosswalk signs. Then we'll be applying few data transformations like resizing, horizontal flip, and normalization. Since we collected the images from different sources, we are doing this normalization so that all the images are on the same scale. And we apply this outcome before we apply this data transformation before we do the training and and testing so that we can maximize the outcome of the learning. Then first, we train our model uh, with the training set, and then we run the model with the test set. We compare the results with the actual labels and calculate the accuracy and confusion matrix. So, the model, how we develop the model. So, first, leveraging the ResNet architecture and by transfer learning, we developed an effective model for traffic signal detection. The transfer learning involves using a pre trained model on the large data set, and we have adapted it for our specific task such that uh, we can use it to detect the images. So to implement this, we used a pre-trained ResNet model from the Torch Vision package, and we modified the final classification layer. Our final classification layer mainly contains a fully connected layer, which extracts 128 features, which is followed by an activation layer and a softmax layer. Next, while training, we have divided the training data into batches of 16. Since our aim is to classify it into 4 classes, we are calculating the cross entropy loss and will be back propagating it to update the weights. And we, after trial and error of different combinations, we achieved our best results with training the model for 10 iterations and a learning rate of 0.01. While testing, the predicted image classes using its training and compare it sorry and using its training, and it compares it with the actual label, and it computes the testing and accuracy and the confusion matrix. Finally, coming to the results. As you can see, our accuracy is 96.97%. On an average, it is 97%. And our model has learned quite very well. At first, we have a loss of 1. Then it slowly reduced to 0.01 after 10 iterations. And this is the confusion matrix for which we have almost identified everything mostly accurately. We do have little minor errors over here, but mostly we have done the accuracy is full and we have predicted the labels correctly. And applications and future enhancement. In the current phase, we have developed the model only to do the classification at one level. In the future classifications, we are planning to identify the speed limit of the particular speed limit signs and the traffic signal light, whether it's a red or blue or a green, sorry, red or yellow or green, and we can warn the riders accordingly. So this is a future plan or the future enhancements for our application. And finally, using the RESNET architecture and transfer learning, we have achieved a better accuracy, and this really helps in detecting the traffic signals, and which can play an important role in the intelligent transportation system. So this is our project, and thank you everyone for your time.